That is me. I would never spit and raise drink. All right. So, I'm sorry, do that again.
78.97 to 83.17.
All right. So what is the statement that we need to make?
We are 92% confident.
Good. We are 92% confident.
At the interval.
Yeah. That the interval.
78.97 to 83.17.
What? 78.97. What was his grades? Okay. To 83.17.
Contains the true mean
Beautiful. Contains the true mean.
of final grades and statistics.
I love it.
If we left the statistics part out, would that make it wrong?
Nah. Sorry.
Okay.
But try to be as true to the actual whatever situation is. Put units if there are units. For grades, you can put a percentage there, but don't. Right? But if it's units like inches or years or something, you want to put that in there.
For the rounding in the interval windows, does it really matter which place we round to?
Well, a decent rule of thumb is you go out at least as many, if not one more, than the data you were given. Right? So here, I think 2 places is plenty. Yeah. But the book has its own kind of rounding rules. They pretty much kind of follow that rule everywhere. Something like that. All right. How we feel about this? Decent? All right. So I'm going to unleash you guys. One little thing I want to say. Let me see. Let's focus on this piece real quick. Has everybody got what they want here?
Yes.
Okay. More than you ever wanted? So if I look at just the error by itself, I can kind of build up something that's kind of what's called feasibility study. How feasible would it be to try to get within 3 inches of length or within 2 points of a grade? So I could work backwards. If I know what the error I want is, if I want to be at most some error, I can work backwards and figure out how large of a sample that would take. And then I can see if it's feasible. If it comes out to be 78, feasible. If it comes out to be 78 million, maybe you want to cut back on the error. Maybe you want to let it be a little bit bigger, right? So if I call this E equals what?
Z.
MC squared, I love it. I was waiting for that. E equals?
Z.
Now how in the world do I start solving this for n? What do you do to solve this for n? Ooh. Every now and again, there's got to be a little algebra in here. Oh, good, Ray.
Yes, thank you. Yeah.
I tasted it. So. I didn't backwash. Don't worry. See, Ray.
Multiply by the square root of n.
Yeah, exactly. So what's really cool about this is I don't want the e up there. I don't want that down there. I can actually just change places. I can multiply this up and divide that down. So one of the most fundamental things from algebra that you can do is just switch the places of those 2 things. So the root n can come up here. I multiply that up, divide the e down, and then of course I do what to both sides? To kill the square root.
Square.
I love the way some of you guys look at me like. This is algebra.
So
right?
you multiplied by the square root of n
Yes.
and then divided by e
Exactly.
to both
So I
sides.
multiply by root n and divided by e.
Okay.
So that went there and that came up there. So it's a nice shortcut. It's one of the most, and it happens a lot in science and physics and so forth and statistics that uses mathematics. If you want to solve for a different letter, very often that's a beautiful thing you can do. Just switch the 2. Don't go overboard and start switching every damn thing. One's up, one's down. Switch. Because 10 equals 20 divided by 2, right? If you switch those, is it still true? Yeah, of course. There you go. So that's why I'm allowed to. I like that. Yeah. So that's why I'm allowed to switch those. Why am I allowed to switch those? Because you can. I love that answer. Because you can. So square both sides, and you get what the sample size has to be. So for some situation, you're going to know how confident you want to be. It's going to give you your z-score. You're going to know this. You're going to know how close you want to be. Do all that, square it. It's going to tell you how large your sample has to be to have that happen. So this is what's called, the kind of question you're going to see in the homework is going to say, how large of a sample do you need to, I know I got to use the formula with solve for n, because that's how large a sample is. So on this handout, I want you to do number 1 all the way out, and then don't worry about 2 yet. You can stare at 2 and freak out about 2.
You have a place symbol in your forehead.
Huh?
You have a place symbol in your forehead.
I have a place in my forehead?
No, the place, the projector.
Oh! Hey, all right.
It looked like you had like a third eye or something.
Wait, where did
It was like dead center.
square come from?
I didn't have any visions.
Oh.
Not yet, anyway. Let's see. We'll see later tonight what happens to me. A little flashback.
We're gonna learn this. Same thing.
Do number 1. Yeah, and let's see. Do me this favor here, so you guys can handle this. I didn't mean to be tricky with this. I meant for this whole problem to relate to the same confidence. So you see here on okay, you're okay. You can't look any further away than that. That kind of sucks. But look here on part B. My God, to figure this out. On part B, which is blah 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 blah. At 95%, make that 93. I want the whole thing about 93, so you don't have to go look at new z-scores. You with me? So the first one's all about 93% confidence. Make part B about 93% confidence, and then make part C with the 90% confidence interval be smaller or larger than the 93. You already made that one, so everything about 90. And several iterations of this thing.
Wait, why 93?
Just because. To make it the same as the first one. Be very careful. You know the process to find the answer.
Okay. How do I find
What's
0?
wrong with this?
1.81.
All right, that's better.
So